Central limit theorem is a very powerful idea in statistics. Basically, it says no matter what kind of dataset you start with, if you take a large number of samples, you will somehow end up with a normal distribution. It's almost kind of magical when you see how it works. And this holds true regardless of the original distribution. You can start with a uniform distribution, a distribution that's heavily skewed to one side, or some sort of exponential distribution. It does not matter. If you take samples many times, you will get a normal distribution. This is A, fascinating in and of itself. B, very useful. Why useful? Well, as it turns out, we know a lot about normal distribution. It is one of the most common types of data distribution. So we know how to analyze the variance, standard deviation, and other aspects of a normal distribution. I will do another video that talks about normal distribution in general. In this video, I'll show you how central limit theorem works using an example. Okay, what I would like to do is, I would like to give you an intuition of how central limit theorem works. As an example, I'm going to use a standard 6-sided dice. So we have the values 1 through 6. And I'm going to draw a probability distribution. I will divide this up into 6 bars, like this. Okay. This is basically a uniform distribution in which it is just as likely to get a 1 as it is to get a 2, a 3, and so on and so forth. In other words, the chance of getting a 1 or any other number, in fact, is 1 in 6, or right around 17% if you like. It's actually 16.666 and keeps going ad infinitum, but this is close enough for our purpose. Now, what I'll do is I'll start taking samples, and let's say the sample size is 4. Basically, I'm going to roll the dice 4 times and see what numbers I'll get. And for the first sample, sample number 1, let's say I get a 1, a 3, a 4, and a 5. And every time I take a sample, I'm going to calculate the mean, or the average of this sample. This is called sample mean. Okay, what do we have here? 1 plus 3 is 4, 4 plus 4 is 8, 8 plus 5 is 13, 13 divided by 4 is 3.25. This is a sample mean for the first round. I'll use the same method and take another sample. For the second sample, let's say I get a 2, a 3, a 4, and a 6. Okay, 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 6 is 15, 15 divided by 4, which gives us 3.75. Okay, let me do one more. This time round, I get a 2, a 3, a 5, and a 6. 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 6 is 16. 16 divided by 4 is 4. And I'll keep doing this. I'll take many more samples, In fact, I'm going to take like hundreds of thousands of samples. And for each sample, I'm going to calculate the sample mean. So I'll end up with a lot more of these. And as I take a bunch of samples, what you'll get is this. I'm going to start a new chart over here. Now we're looking at the sample means. And all the sample means are going to be somewhere between 1 and 6. The sample mean of 1 is going to be very rare, but it is possible. You will see that in a minute. What I'll do is, I'll make a histogram of all the sample means. For the first sample, the mean was 3.25, so it should be right around here. And I'll plot this on this chart. I'll add one block like this. The second sample mean was 3.75, which should be around here, so I'm going to plot it. The third sample was 4, which should be a little further out to the right, like this. And I keep plotting the sample means. Let's say the next sample mean was a 3.25 again. So I add another block here. I see another sample mean of 4. Maybe this one is a 3 and a 2.5, and I do this a bunch of times. You see other in-betweeny numbers too. As you keep plotting, you're going to see something very familiar. You're going to see that many of these points are kind of clustered around the middle, and there will be fewer observations to either side of the chart. Especially if you look at the very end, getting a sample mean of 1 is not impossible, but very rare. And if you think about it, it should make sense. If you get a sample mean of 1, what that means is you roll the dice 4 times, and every single time you get a 1. That's how you get a sample mean of 1. So you can see that that's not very likely. You see very few cases of that, if any. And the same story for the sample mean of 6. And remember, we have hundreds of thousands of these plots. You'll start to see the sample means approximate normal distribution. This is partly why we see normal distribution everywhere. If you remember, we started with a uniform distribution. It looked nothing like a normal distribution. But as we took samples and kept plotting the sample means, we started to see something like a normal distribution. And this works with pretty much any other kind of data distribution. Hopefully, this gives you a good intuition of how central limit theorem works. Okay, thank you for watching. I hope this was useful. If you like this video, please subscribe to this channel up here. If you'd like to watch more videos like this one, you can keep watching the series down here. Thank you for watching. See you in the next video.